The next type is tapered wall. If I go to my wall here now, and you can see that if I go to my generic 200 millimeters, I will put this to be vertical. If I want to use my tapered wall, this cross section to be tapered, I have to create a layer inside of this compound structure, which will have the variable thickness, because otherwise it will not work. So I will create a new type. Let's say this will be my generic 200 millimeters tapered. And now if I choose my variable thickness, let's go back here, you can see my parameters is construction, graphics, and so on. If I choose my variable thickness for this layer, hit OK, you can see that now I have new parameters here in my type definition of the wall, which is cross-section definition, which is telling me the default exterior angle, default interior angle, and the width measured at. So we will take a look on these three parameters now. Let's first create this wall. Let's use my section view to be able to see it better. So now you can see that I have my wall. Let's put here a base offset, let's say 500. I will create my cross section to be tapered now. So now it would use my type parameters, which are in this instance 0. But let's go to this section view. And I will go with my default exterior angle to be, let's say, 2 degrees. If I hit apply, you can see that it did something like this. And if I go to my default interior angle, hit 2 degrees, you can see that it did something like this. And what this does is that this default exterior angle is being measured at the exterior side of this wall. So if I put here back 0 for you to be better able to see this, you can see that it looks like this now. Let's put this to consistent colors. And if I hit my wall, you can see that these flip arrows are telling me my exterior side of the wall. So you can see that this parameter, default exterior angle, is giving me the tapering on this exterior side of this wall. So if I go to my default interior angle, let's put here 2 degrees, you can see that it get me tapering on my interior side of the wall. So this is the exterior and interior. And the next thing is the width measured at parameter, which can be either top, base, or bottom. So what this means is that this width of the wall, which is here 200 millimeters, which comes from this structure, now it is measured at the top of the wall. So you can see that in my section, if I try to measure this wall, let's put this to be without the slant, so it will be easier for me to snap. So you can see that now it is measuring this 200 millimeters at the top of this wall. So the next possible setting is the base. Let's change this to the base. Now you can see that the top is actually 43 millimeters. And this wall has the base, which is here on the base constraint, which is level 1. So on this level 1, it will be measuring my 200 millimeters. So you can see that if I go here and I measure this will be my width of the wall. And the last setting is here, the bottom. So now it is measuring, you can see that now it is 183 millimeters. This one is 25. And now here on the bottom, you can see that it is 200 millimeters. Now let's say that I have my type parameters set like this, and I want to have my instance parameters or my wall different, but I do not want to change the type parameters. I can do this here in the cross-section definition with the parameter enable angle overrides. If I hit this, you can see that now I am able to override the exterior angle and the interior angle. Here in this exterior angle and interior angle, the positive values of these angles, let's say that here the positive value, I will put it to 0 again. So you can see that now it is 200 millimeters all the way. If I put here 2 degrees, it will tilt the top of the wall to the center of the wall. If I put here the negative value, let's say -2, it will tilt the top of the wall to the exterior. So this is the way how these positive and negative values work with the tapered walls. So positive value will tilt the top to the center of the wall, negative value will tilt the top to the exterior of the wall. Then there is an error that, let's say that I have my tapered wall which has this layer which is variable thickness, and if my layer which has variable thickness would fall below 0, I would get an error. Let's try this now. Let's say like this. You can see that it cannot create a wall because it would intersect itself, and it would actually need either to change the angle or the width of the wall, or you would need to change or modify the height of the wall for this to be able to create this wall. So you have to be careful with that. The next thing is inserts. So I will put this to be, let's say, 2 and 2. Okay, I will change this to be measured at the top. So something like this. And now if I insert my window here, you can see again what it does. Now I have my window vertical. If I put this to be slant along the exterior, you can see that it will cut like this. Or I can go with the slant along the interior orientation, so it will tilt on the other side. If I put here interior angle as well, you can see that now it is slanting like this. So this is how you modify the orientation of the inserts inside of the tapered walls. And the last thing is that for the tapered walls, the wall wrapping or the layer wrapping doesn't work. So if I go here and insert my layer, let's put this 15, it is set to be wrapping. And I have wrapping at inserts, let's say both. You can see that it will not wrap even if I put like inset of this window and my exterior wall closure to be 50 and 50. So for the tapered walls it is not working. If I change this to be vertical, now you can see that the layer wrapping is working, but for the tapered definition it is not working.